Well, thank you, Mindy, very much. Thank you all. What a pleasure to get to be here. Ceres is an incredibly important operation, and the people who make it happen are why it's so important. Bob Massey is one of my great heroes in this work and has been for a very long time. And Mindy is carrying on magnificently the work that he's begun, and the rest of that crew, I know, is able to work not only in the boardrooms but out in the streets as well, because I've seen them organize all kinds of things. Ceres is one of the very few places, I think, that enjoys the complete trust of everyone around the environmental community, from the most activist hardcore into the middle of the business world, and they perform a very important function as a result, as a kind of bridge where people can and should be able to get together and talk and plan and think. And that's what I'm going to try to do just a little bit with you all here today. I want to do just what Mindy said, to sort of encourage us all to be picking up the pace, to be thinking about the true magnitude of this issue. We're at a moment when it is possible for environmentalists to stand shoulder to shoulder with much of the business community on this issue of global warming. My great hope is that that moment will continue. For that to happen, you will need to move quickly and decisively. There are people in the environmental community who think that that's impossible, but I hope very much that it is not, and I think it's quite likely that we'll be able to continue this very fruitful partnership. I want to talk to you, first of all, about the magnitude of the problem that we face. By now, everybody in America, or almost everybody, is pretty well aware that global warming is real and that it's an issue and a threat. But I'm not sure that everybody has quite figured out both the magnitude and the rapidity of that, with which that threat is bearing down upon us. And so I'm going to just give you a little bit of background, things you already know, just to kind of set this in a context. Now, as Mindy said, I wrote the first book about climate change way back in 1989. And at the time, it was a hypothesis, this idea that we were burning enough coal and gas and oil, and hence putting enough carbon in the atmosphere to materially alter the climate, seemed, on the one hand, scientifically sound. We knew enough about the molecular structure of CO2 to be able to predict fairly powerfully its effects. And on the other hand, it seemed emotionally counterintuitive. How could one species, ours, have really grown large enough to alter something as fundamental as climate? Because, of course, when you change the amount of the sun's energy that you trap in this narrow envelope of atmosphere, you change everything. Everything that happens on the surface of the Earth, except tectonic and volcanic forces, is driven by that increment of the sun's energy. So, to figure out where the truth lay, science went to work, and they went to work more powerfully than they'd ever gone to work on any similar issue over a similar period of time. Enormous amount of resources, enormous amount of talent, enormous amount of time went into every possible kind of experiment that you can think of. Satellites and weather balloons, drilling glacial cores, whatever it is that you could imagine. That's what people were at work on, especially refining the extremely large and powerful computer models that allow us to forecast what's going on with the climate. By 1995, a solid consensus had emerged. The UN, working through the Intergovernmental Panel on Climate Change, all the world's climatologists, in essence, gave humanity a kind of, announced a kind of signal moment. Yes, we had grown that large. We were casting a very large shadow across the planet. They said we were heating up the world and that it was going to be a serious problem. Since that point in 1995, there's been an immense amount of science done, but all of it has served merely to confirm and deepen and strengthen that consensus reached in those years. Past 1995, there's been no serious scientific dispute about the basic outline of what's going on. Indeed, since 1995, it's been as if the planet itself has been carefully peer-reviewing that science just to make sure it was correct. We have had 9 of the 10 warmest years on record in that period, one warm year after another. We've begun to see, in fact, that 20 years ago we underestimated the vulnerability of the planet to sort of how finely balanced the planet's systems were. So far, human beings have raised the temperature of the Earth about 1 degree Fahrenheit. 20 years ago, we would have said that that would be sort of the threshold, that we'd be able to see global warming effects, but that the biggest ones would still be another half a degree or a degree off. It turns out that all the feedbacks have been positive. None of the hopeful negative feedbacks that would have cooled the planet have emerged, and hence this thing is happening more quickly than we even then thought would happen. The rock-solid middle consensus now for what will happen in the course of this century without dramatic change in human behavior, not the worst-case scenario, the middle-case estimate enshrined in the last set of IPCC documents released earlier this winter, is that we can expect a further increase of 5 degrees Fahrenheit in global average temperature before the century is out. 5 degrees is a lot, taking us from roughly 60 degrees globally average to roughly 65. This is not warmer than it's been in human history. This is not warmer than it's been in human prehistory. This is warmer than it's been since really before the beginning of primate evolution, okay? We're talking about extremely large changes unless we're able to get very quickly some handle on what's going on. The set of feedbacks that are beginning to amplify the human-caused warming are long and scary. The albedo, the reflectivity of the Earth, is beginning to change and change pretty quickly. When that pack ice above the Arctic starts to melt, it replaces a nice white reflective surface with a nice absorptive blue one. Instead of 90% of the sun's rays or 80% reflecting back out to space, about 80% are absorbed by that blue water, amping up this cycle. Forests at this latitude are now beginning to turn from sinks for carbon, places where trees and soil can take up that carbon and sequester it, into sources. As they warm, as growing seasons extend and microbial decay in the soil increases, more and more of that carbon, until now stored safely there, is being liberated into the atmosphere. In the far north, sources of methane, another potent greenhouse gas, are now appearing in abundance as the tundra and permafrost above them melt. There are places in the Siberian Arctic where ponds and streams haven't frozen even at the height of winter in recent years because there's so much methane bubbling out constantly through them. That's in a sense, the good news scenario for where we are, okay? That's if things behave the way that we pretty much now expect them to. There are also a series, and they seem to be becoming more and more probable, of extremely large discontinuous events that would make this scenario even worse. And the one that's achieved the most prominence, and the one that's had scientists who have been concerned and worried and working hard, starting with a real note of panic in their voices in recent years, are things like, most prominently, our emerging understanding of the vulnerability of the large ice sheets above Greenland and the West Antarctic. Originally we assumed that those would be stable for a very long time, that we could begin the process of melting them, but that it would take quite a while, because after all, they're a 1.5 mile thick sheet of ice. There's a lot of inertia in a system like that. The assumption was that temperature would go up, a little snow would melt on the top, you'd get some pools of water which would politely evaporate out into the atmosphere, and it would take a long time. That's not what's happening. That water is finding fissures and cracks in systems that turn out to be more dynamic than people had realized. That water is quickly getting to the bottom of those ice sheets and beginning to grease the skids for their slide into the ocean, raising the possibility of rather more rapid sea level rise than people had thought about in the past. There's enough ice above Greenland alone to raise the sea level about 25 feet. We don't want that to happen.